Now today we are going to go over merge sort, and before we go over what merge sort is, I actually want to go over one more thing, and that's going to be divide and conquer algorithm. And why do we want to go over this? The reason is because merge sort uses this approach to solve problem, which in our case is sorting an array. Now, what is divide and conquer algorithm? It is a strategy for solving large problems by using recursion, and recursion is spelled wrong, no T, and follows the approach. So there are 3 steps to it. First one being obviously divide, and second one being conquer, and last one being combine. So step 1, we want to divide our problem into multiple sub-problems. Now let's say that we have our array, so -2, 2, -1, 1, 0, and 0. So this handles positives, negatives, and duplicates. What we're going to do is we are going to somehow divide this array into sub-arrays. And the next one is to conquer our sub-arrays. So conquer the sub-problems by solving them. So we want to somehow solve these sub-arrays. And then finally, we want to combine the solutions of the sub-problems to get the solution for the actual problem. So we are going to divide our arrays into sub-arrays, and we want to find solutions for each. One, solution 2, solution 3, solution 4, etc. And then we want to combine all this and have a one final output that's going to have us a sorted array. If you guys find this helpful, make sure you guys like and subscribe. Thanks. Now let's go over how exactly merge sort work. So merge sort is, like we said, it's a divide and conquer type of sorting algorithm, and it follows 3 steps, same as our divide and conquer. Step 1 is to divide. It's going to divide our input array into single element arrays. So this is really important, and this is handled by recursion. Next one is we are going to sort each element, and as we sort it, we are going to merge it little by little, and you'll see that as we make our illustration later. And finally, we want to have one final output by combining everything. Okay, so now that we know the steps of merge sort, let's make an illustration. Let's say that we have an array and we have 6 elements in it. So how can we divide our array? So what we're going to do is we're going to keep dividing them in half to left part and the right part until we get single element arrays. So we have 6 elements. So this is going to be divided into 2, and that's going to be -2, 2, -1, and 1, 0, and 0. And now we are going to divide this again, and that's going to be -2 here, and 2 and -1 here, 1, 0, and 0. And since -2 is a single element, we are just going to bring that down. We are going to divide this one, bring this one down, divide this one. So we divided pretty much 3 times. We divided here, and then divided here. And finally, we got our single element arrays. Now, we need to sort and merge our arrays. Okay, this -2 is already sorted because it only has 1 element. And next one, we have -1 and 2. Well, if you were to sort that, it will be -1 here and then 2. This one we bring down because it's only 1 element. And this one, they're the same, so we have 0 and 0. Next, we do the same thing. We combine these 2. So we combined these 2 here, these 2 here. -2 comes first, -1, and then 2. Combine these 2, it's going to be 0, 0, and 1. And finally, we combine these 2, and we get -2, -1, 0, 0, 1, and 2. As you can see, we have our sorted array, and this is our final combined product. So as you can see here, this is divide, and this is pretty much conquer, and this is combine. So as you can see, we had 3 steps to it. Step 1, divide, 2, conquer, and 3, combine. Now let's briefly talk about our time complexity. You don't have to understand everything because we are going to go over this one more time after we code our solution. But just do note that best, average, and worst case for our time complexity is the same. And it's because regardless of how our array is sorted, we are going to do the same operation over and over and over again. So it doesn't matter what kind of array we have, even if it's sorted for now. we are going to divide it and then conquer it and then combine it. Even if this array is, let's say that it was in reverse direction and we want ascending, we're going to do the same thing. We are going to divide, conquer, and then combine. We are going to repeat that whole operation over and over again. That's why we have same time complexity. And as for space complexity, it's O of n and O log n, but that obviously simplifies to O of n. And this is the space needed for divided lists in our elements and for our result. And finally, O of n for our stack frames, but this is non-dominant, so we get rid of that and we are left with O of n. And I am actually going to show you a example where we actually don't have to have this part. So this is actually to simply put, auxiliary space, and this is where we are going to store our result. I think this might be a little confusing. So for optimized solution, we actually only need O of n space because we are going to use in place method. But keep in mind that standard merge sort functions are implemented using a space complexity of O of n, but we like to optimize things. So we are going to do it in O of log n space complexity. Now I want to illustrate how exactly merge sort works in step by step. And we did mention that first thing merge sort does is it divides, it conquers, and then it combines the result. And we kind of illustrated that in our first intro to merge sort video. But when we actually run the code, it's actually kind of different. And here I want to just illustrate that. So when merge sort is ran on this original input, it's going to actually only look at the left half of the array. So first it's going to look at -3, 3, -2, and 2. And again, this is the order of operations that our code is going to run. So it's not like it's going to look at the left side and then the right side simultaneously. It doesn't do that. It looks at the left side first. So for now, I'm just going to delete my right array. Okay, next thing it does is, well, first thing that we do want to do actually is divide. So it's going to keep dividing that. But this time, it's only going to look at, again, the left side. So the left half of the array. So this is step 3. And then again, this time is going to be single elements. So it's going to split those two. So this is step 4. And now, what do you think we're going to do? We are actually going to go to step 2 and conquer our arrays. So sort this, and that's going to be -3 and 3. And this is step 5. And we actually go back up to our step 2 array, and we look at the right side. -2 and 2, we split this. So this is step 6. And the next one is -2 and 2, our single element arrays. That's step 7. And again, we merge those two. We sort it, and this is step 8. Now we actually don't go back up to our step 1 and look at the right side. We actually have to merge this side first. So that's going to be -3, -2, 2, and 3. So do you see the pattern now? What we do is we divide and conquer and combine the leftmost side first, and then we go to right of the left side. So steps 6 through 7 to 8, and then we combine our left result and get -3, -2, 2, and 3. And now we look at our right side, which is going to be -1, 1, 0, and 0. And this is step 10. And now again, like before, we look at the left half first. So this is step 11. We split this into single array elements, 1 and 1. That's 12. We combine this, which is -1 and 1. Step 14, we look at the right side, the rightermost side. So that's 0 and 0. Split this. Step 15, step 16, we combine these two, merges. So that's 0 and 0. We combine these two, which is going to be step 17. And we get -1, 0, 0, and 1. And finally, we merge these, which is going to give us our final array, -1, 0, 0, 1, 2, and 3. So step 18. So do you guys see the pattern? So first thing we do is leftmost side of the operation, and then we do left of right, or right of left, and then we do right, left, and then finally it's going to be right, right. So if I were to just illustrate that, it would be this, which is 1. Actually, let's put it this way. So if I were to illustrate, that would be step 1, step 2, step 3, step 4. And then we finally merge our arrays and get the final result. So this is how merge sort works in order of operation. So key thing to take away is that it's not simultaneous. It's not like we do split of left and right at the same time. We actually look at the, again, leftmost, left right, right left, and right right. And then finally get our result. Now let's go over our first solution. Our first solution, as always, is going to be the easiest to code and understand. But this code is going to have a time complexity of O of n squared. So quadratic time complexity. And the reason is because we are going to use an array method called shift. And if you know the time complexity of shift, that's going to be O of n. So what does shift do? So shift removes and returns the first element in our array. Well, if it's just removing and returning that, why is it O of n? And the reason is because for the remaining elements, we have to reindex every one of them. So if you look at number 3, that's going to be at index 0, whereas before it was index 1, and next one is going to be index 1, 2, 3, and 4, and so on and so forth. So we have to reindex every element. That's why it's going to be O of n. So let's start coding, but look at our pseudocode and try it on your own if you can't. If you can't, come back to the video and we will start coding now. First thing we do is create a function that's going to take our array. I already did that, and I'm going to make another function that's going to be called merge, and this is actually going to take 2 arrays, left and right, and I just capitalize L and R because I just think it's easier to read that way, just for me. If you want, you can just lowercase it. It's totally up to you. Our left and right, it's going to be an array, and if you remember, we kept splitting our array, right? So left is going to represent the left side of the array, and then right is going to be right element or right array. And I want to create a variable. I'm just going to name it result, and this is going to be an empty array. So here I'm going to store all my result, my sorted array. And later we are actually going to optimize this so that we don't need this. So we are going to have a space complexity of O log n, but for now we will just leave it here because it's, again, easier to understand. First, I want to loop through my arrays, and my condition is going to be left.length, and right.length. So I want to iterate through my array, left and right array, as long as my left and right array isn't empty. And I need my comparing statement. So if left at index 0, so if the first element of left is less than right at index 0, what do we want to do? We want to result.push at left index 0. If you did that, it's actually not correct because, well, if we are iterating through our left and right array as long as the length isn't 0, right, for any one of them. Well, if you were to just push in the first number, that wouldn't really change the length of our array. We'll just keep pushing in that first number. So what do we want to do? We want to actually shift, and that's why we said in the beginning we are using shift. And remember, this is again O of n operation. So I'm putting in the smaller element to my result array. Now I need the other case. Else is going to be result.push right shift. If left at index 0 is greater than right at index 0, I want to put in the right element. So that's what I'm doing here. So in this statement, what I'm doing is I'm pretty much comparing, sorting, and merging my arrays. But what if it was the case that our left array had 2 elements and right was 1 element array? And when we shifted our right element, it became 2 elements in our right array because right element happened to be the smallest number, and we have 2 elements left over in our left array. How are we going to handle that? So we need a way to add leftover elements to our result array. and this is this step. So how are we going to handle that? Well, what we can do is we can just add whatever is left over to this result array. Well, what I can do is we want to return our array. So return array dot concat. So we are concatenating our leftover elements. So left and concat right. And I actually wrote something wrong. This should be result, not array. I'm concatenating to my sorted array. And you might think, well, does left have to come first or right have to come first? That's actually a question that I had when I was learning merge sort. And the fact is, it does not matter because remember, this will run when we have 0 elements. So when our array is empty for right or left element. But as long as we have elements in left and right array, this is going to run. So as soon as we have 0 elements in, for example, let's say right side of the array, we are going to run this code and we are going to come straight to this and then just pass in all the elements to our result array. And if it was the case that our right element was empty, I mean, we are adding an empty array to our result, so it wouldn't matter. And again, what if it was the case that our left array was empty and our right element had 2 elements? Well, we are adding empty array to result variable, so that's not gonna do anything, right? So it won't affect our result. So order of this does not matter. Well, result have to come first because we're concatenating to our result array, but you can't have right here, you can't have left here, it doesn't matter. And there is actually another way to write this. If you're familiar with spread operator, we can do something like return ... result ... left and ... right. So we're taking all the elements out from our result, our left array and our right array. And again, remember that one of them, either left or right, is going to be empty. So again, order does not matter. Well, if that didn't confuse you, you're better than me, because when I first started, I was wondering why does something have to come before or after, but it ended up being that the case that it did not matter because again, one of them is going to be empty. Now we need our base case, and remember, merge sort is a divide and conquer algorithm, so it's going to use recursion. You can actually cut this out and put it outside of this function, but I just prefer to do it this way because obviously I'm going to code multiple solutions and it just works easier for me. Now let's have our base case. So if array.length is equal to 1, I want to return that array. And remember, what merge sort does is it's going to split our array until we have single elements in our array. So when it hits our base case, it's going to return that array. It's going to return that single element array. Now, finally, I want to create a variable. So const, and I'm just going to name it m, and this is going to point to our middle index. And I'm going to just round down. You can round up if you like, but I prefer to round down. So it's going to be left.length plus right.length. And then we are going to divide it by 2. And something is wrong. Left is not defined. Oh, and that's because I made a mistake. This should be just array.length. Okay, that looks good. Now I want to create an array or variable to save the left half of the array, which will run recursively. Okay, that sounds confusing, but what we want to actually do is we want to create a variable, and let's call it left, and we are going to recursively run our merge sort function. So merge sort 1, and we are going to only put in the left portion of the array. So if it was the first one, it would be -3, 3, -2, and 2, and our index or m would point to this one. We have how many elements? We have 8 elements. So 8 divided by 2 is 4. So 0, 1, 2, 3, 4. It will point to this one actually. And how can we slice or get just these 4 numbers? Well, I just said it. We can actually slice our array. So array.slice, and we want to index 0 to index m. And we want to do the same thing, but this is going to be our right side of the array, and it's going to be array.slice m. And finally, what do we want to do? We want to recursively run our function. So return merge, and we are going to pass in two arrays, which is going to be left and which is going to be right. And as you can see, our array is sorted. So how does actually this work? Well, if you wanted to avoid confusion, you could have done it this way. It's pretty much the same thing. Const left is going to equal to array.slice 0 to index m. Next one is going to be right side of the array, and we have this. But when we recursively run our merge function, we want to make a parentheses around this and then call merge sort on this one, and recursively run merge sort on this one, which is same thing again, but I prefer it this way because I think it looks cleaner. So let's just delete that. Okay, let's go over how this code actually works. Well, it looks confusing because we are recursively running this over here, and then we're recursively running this merge function over here, passing it left and right. So at first, what we do is we hit this line is array length equal to 1. If not, we will keep going through our code. So we declare a function, we save the middle index, declare another function, and we are going to recursively call our merge sort function. And why do we do this? Well, we want to first divide our array. This is what it's exactly doing. So divide here and divide here. And if you remember the diagram, we kept dividing until we had single elements, right? So this is what it's first doing, even before going through merge function. It's recursively dividing our array until we hit our base case, which is when array is equal to length of 1. We are returning that single element array and we are passing it into our merge function. So we do that recursively and run this function to compare and sort our function, and then finally merge everything and return the final result here. So this is returning final result, and here we're doing compare and sort. And so I think our merge function is relatively easier to comprehend because it's just doing this, but I think the hard part comes from our recursive case, this whole code. Just remember that whatever this is, it's just dividing our array into single elements, and it's passing that single element array. It returns it, and it returns it into left here and then right here. And as it goes through our code, it obviously sorts our array and we get our final result, which seems correct. Now what we're going to do is we are actually going to go through this code and do something similar to what we did with making our step-by-step diagram. So I just want to show that with code. So this is our function. We are pretty much gonna run this step by step. So first, merge sort is going to run, and we have our array, which is this original input, and it hits our if statement. That's false. We get our middle index, which is 4. As you can see, it changed. And we hit our next line, which is left. And as you can see, we are looking at the left half of the array, which is -3, 3, and -2. And we hit our merge function, but that's not going to run because our left and right is undefined for now. So we go back to our if statement, our base case. Well, is the length 1? No, it's not. We find our middle index, and again we hit our left constant variable and we divide our array again. And as you can see, we have -3 and 3. So the steps that we follow is exactly the same as our illustration. So now we are just simply dividing our leftmost array into single elements. So we find our middle index again, then we have -3, our base case, and we are going to return that -3 because our if function now returns true. So it returned the value, and as you can see, it's an array with -3, and you can see that our left value now became -3, array with -3. So we actually have a value for our merge function now, whereas before it was undefined. So we have -3 for our left, but right now right is undefined for now. So we're gonna keep going through, and you can see that our right variable runs with merge sort, and our array is -3. Our base case runs and it's going to return that array. And let's check. As you can see, we have 3 as our result or return value. Now we have values for our merge function now, which is -3 and 3, and we are able to run our merge function since we have our valid values. We had our result, we set it equal to an empty array, and we go through our loop where we compare and sort elements, and left has a length of 1, right has a length of 1. So this while loop is going to run. Well, since -3 is smaller than 3, we are going to push in -3 to our result, and you'll see that here. And as you can see, we have -3 in that array, but now we have a length of 0 for our left array. So this while loop is going to fail, and it's going to go to this return statement where we add all the leftover elements to our result array. So that's why we are going to have -3 and 3 as our sorted array. And now our left is -3 and 3, and we are going to go back up to this array and look at -2 and 2. We're gonna divide that and then sort it and merge it and set that equal to our right side of the array. So let's go through the steps. I'll go a little faster this time. So -2 and 2, we get our index, divide our array. Our left returned -2. So right now, again, we are doing the right side of our first left side. So if you remember the illustration, so step 2, left, right. First thing we did was left, left. We are now doing left, right. So as you can see now, we have -2 as left and 2 as right over here. And we are going to sort and merge them, and that's going to give us -2 and 2. And just a quick quiz. What do you think we are going to get for our left and right value? Well, our left should be -3 and 3, which is sorted, and we did that with our function. And then next, right is going to be -2 and 2, which we compared and sorted. Okay, so now we have -3 and 3, -2 and 2 as our right. And now we want to merge these two. So we should expect -3, -2, 2, and 3. And let's go through this fast. It's the same operation. So now you can see that our left side is sorted, -3, 2, and 2, and 3. So we did our left side of the sorting, comparing, and combining our result. Now we need to just do the exact same step for our right side, and I am actually just going to skip through this really fast, but you should know that we are going to get the right side sorted, so it's going to be -1, 0, 0, and 1 as our right. And finally, we are going to run our merge function again, and that's going to return our final sorted array. And as you can see, we have our right side sorted, -1, 0, 0, and 1. So now we have our final return value, which has an array, 8 elements in our array. And if you open this up, you can see that all our elements are sorted. So -3, 2, 1, and all the way to 1 to 3. And this is how merge sort. Now we are going to go over our second solution. We are going to optimize this a little bit because our time complexity isn't going to be O of n squared. Obviously, the logic of the merge sort doesn't change. It's just different code, but more efficient than our first one. It's actually going to look pretty similar to our first solution, but there are some differences. And if you can try it on your own after you read the pseudocode, do that. And if not, if you can't get it, come back to the video because we will start our solution now. So first thing I want to do is make my function, and I want to also make my merge function that handles sorting, comparing, and merging my array. So I am going to name it left for my left array and right for my right array. Next thing I want to do is I want to create a variable that's going to store my result and set that into an empty array. And obviously this solution uses a extra space for our result, so it's going to be O of n. And we are going to optimize this later so that we don't use this extra temporary space for our solution or our result. And I am just going to return that later. Okay, so first thing I want to do is I want to iterate through my array, left and right. And actually before that, I want to create a variable, let L is equal to R is equal to 0. So I'm creating two variables that's going to represent indexes. Left is going to represent left index, and R is going to represent right index. And I want to iterate through my left and right array, right, as long as I have items in them. So before we did left.length and right.length. So as long as there were items in our array, we were able to loop through our while loop. But remember that we are not going to use shift this time. So it's going to be as long as left index is less than length of the array and right is also less than right length. We want to pretty much do the same thing. If left at index L is smaller than right at index R, what we want to do, we want to push our number in there. So push in the smaller number, but actually let's make our curly braces. Result dot push, and we're gonna push in that smaller number left at index L. And another thing that we have to do is we need to increment index by 1 because we are not deleting any elements. And we need the other case when right is greater than left. So we want to do pretty much the opposite. We are going to push in right at index R, increment R by 1 each time. So this loop is going to run as long as left index and right index is smaller than the length of the array. And this is just iterating through our array and just pushing in smaller number after comparing the two. And now we have to handle our rest of the elements, right? Before we did something like return. We used a spread operator to result ... left and right. Well, this isn't gonna work here because we are not getting rid of any elements in our original left and right array. So what can we do? We are going to use while loop for that, and I'll just delete this. So while we have left and left index is less than the length of the array, we are going to result dot push left index L. And again, increment left index by 1. So what we're doing here is add left over elements to result. And this is from left array. Now we need to do the same for our right array. So it's going to look pretty much the same as long as right index is less than right dot length. So length of the array. We are going to push result dot push right at index R, and we are going to increment that index by 1. And obviously this handles leftover elements for our right side of the array. And if any one of them is false, obviously it's not gonna run, it's just gonna run the other. And you can combine the two if you want, but let's just leave it like this. Now we need to handle pretty much our dividing portion of the solution. So first we need our base case. So array.length is equal to 1. We want to return that array. So that looks good. And now what do you have to do? We have to make our variable for our middle index. And let's just round down array.length. And we just divide that by 2. And we need to create our left variable. So this is going to represent the left side of the array. And we want to recursively call our merge sort function so that we can recursively divide our array. So that's going to be array.slice. Since it's left, it's going to be index 0 to m, our middle index. And then we pretty much want to do the same thing. So I'm just gonna copy this. We will name this right. We just have to change our slice. We are going to start at index m. And I spelled something wrong. Math.4. It looks good. Now our final function. We are going to return merge left and right. Right, everything is green, so it looks good. Let's check. Right, we now have our sorted array. So I won't go over the logic of this because it's exact the same. I did multiple diagrams and we went over the code one by one pretty much for the whole thing. But just know that this is in charge of sorting, merging, comparing as long as there are elements in our, well, not elements in our array, but as long as left index and the right index is smaller than their respective array. And we are pushing in the leftover arrays with these two while loops, and this one is in charge of left while this one is in charge of right. And here we're just simply recursively dividing our array. So I guess the key point to take away from this solution is the fact that we are using indexes instead of shifting elements. Before, we shifted elements and just got rid of that and pushed that into our result variable, but we are using just indexes to just do that. And this is more efficient because we don't have to re-index our array every time we take element out. So this is going to have a faster time complexity, and that's going to be of n log n, because we don't have a nested loop in our while loop over here. So that's the main difference. Overall code is the same. And next we are going to go over our most efficient merge sort solution, where we use in place method. And it's actually going to look really similar to this one. Now we are going to code our final solution, and like we said before, this will be the optimized solution where we use in place method. And obviously we are going to have a space complexity of O of log n. And before that, we always had O of n because we had that result variable where we stored our result to. So for this one, we only need O of n log space, and that's for stack frames used by the recursion only. And if you remember from our previous video where we went over our code step by step, when we had 8 elements, we have how many? 6? Yeah, 8 elements. You probably saw that we only had 3 stack frames at max at one time. So if you were to half this and try to figure out the number of times we can half this, so first it will be 4, then it will be 2. So we did 2 halvings, and then it will be 1 element. So we did total of 3 halving operations. So if you remember from our time complexity or space complexity video, that's exactly the definition of logarithmic time or space complexity. And that's what we have over here for our method, our last in place merge sort solution. So now let's start coding, and this will be pretty much the same as our second solution, but again, it's just optimized. So I'm going to make my merge function like always. And this one is going to be a little bit different because it's going to take 3 parameters. It's going to take our original array, left array, and right array. And I'm just going to return my array later. And I'm going to declare 3 variables, and one is going to represent array, left, and right. So I'm just going to name it A, left for left, and R for right. Now I need my while loop. So as long as left index is less than the length, so this part is pretty much the same. Right is less than right dot length. Now we check if element at left index is less than element at right index. What we are going to do is we are going to overwrite our first element in our original array. So that's going to be represented by array at index A, and with that we set that equal to the lower value of the 2, which is going to be left in our case, and we increment L by 1 here. And we do the same thing else. We want the other case when right is smaller, so that's going to be array at index A, that's going to equal to right at index R. And finally we increment right index by 1, and we have to do one more thing. We are going to increment the original input index by 1 here. Or you could have done something like increment it here and then here, but let's just keep it to 1. But if you prefer the other one, it's up to you. You can just leave it like that. Okay, now we need to handle our leftover elements. And you remember how we had 2 different while loops? But this time, let's try something else. Different code, but essentially it's going to do the same thing. So while left is less than left dot length, or right is less than right dot length, if left index is less than the left array, length of left array, what do you want to do? Well, we want to put it into overwrite our element array with our left element. And here I want to increment L by 1 each time also. And else, and this is the other case, we want to override our array with the right element. And we are going to increment R index by 1 and increment original index by 1 also. And finally, we return our array. Okay, so that looks good for now. But now we need to handle dividing our array. So if array at if length of the array is equal to 1, when we have single element arrays, we want to return our array. Okay, now same as before, we need to find our middle index, and I'm going to name it M, and we are going to round down and pass in the length of the array and divide it by 2. Now we need our left side of the array, and that's going to be recursively called. So merge sort, and let's slice our array. So we want to pass in the left side, which is going to be 0 to M. Just going to copy this and then name it right, and that's going to be slicing starting at index M. And finally, we run our merge function. Merge, and remember that we had 3 parameters for this one. So original array, left array, and the right array, and we should get our result. Okay, so let's not go over this one because we ran over that many times, but here our merge function, that's what's important. We declared 3 variables. A represents index of the original array, left, obviously L left, and R right index. And same as always, we check, well, is the index of left and right less than the length of the array? If that is the case, we are going to run this code, and if left element is smaller than the right one at index L and R, we overwrite the current position or current index of our input array with the left element, and we increase index of left array by 1, and we do the same for the other case where right is smaller. So here we are comparing with this if statement. We are essentially sorting our original input array and merging it, I guess, this loop and here, because we are kind of overriding in our original array. So that's what it does, and then we increment our index by 1 each time we add some element to it. And finally, we return our array. So again, this one uses in place method. Space complexity is better, and the code itself isn't really that much different from our second solution. It just uses 1 extra index to point to the current index for our input array. So that's it for our optimized merge sort, and we will probably go over quick sort next. So now that we know how exactly our merge sort function works step by step, I want to go over time complexity. We did kind of mention it in the beginning, but we will probably have a better understanding of it right now. So for merge sort, all the time complexity is the same for best, average, and worst. And why was that? Why was it the case that they're all the same? Well, it's because no matter how our array is sorted, we are doing same operation over and over again using recursion. So we do all of login operations, and that's partitioning or splitting or dividing arrays. So this was step 1 to merge sort. We divide our array. And if you remember how we went over our code one by one, and you probably saw that we had only 3 stack frames, and this is where the O of log n comes from. And we have O of n, and this is for linear time to compare and merge the 2 halves. If you remember, we were comparing our left number and the right number simultaneously, and we were doing that for all the numbers. So that's why it's going to be O of n. So if you combine those two, it's going to be O of n times O of log n. And finally, our space complexity. Well, the original implementation of merge sort is like the default space complexity is O of n, which was for our solution 1 and 2. But we were able to actually optimize solution so that we didn't need this O of n extra space for our result. And we ended up being able to code our solution using O of log n space, which just required 3 stack frames for our input array. So that was O log n. So that's it for merge sort.